if they want to. This is quite a lot of lightning and thunder here, actually. It's not like Kenyan lightning and thunder, which comes, I remember every time when it came at night, it was very good. But here it's daytime now, but we are getting much lightning and thunder. So if my electricity suddenly goes off, you'll know what's happening, but I will come back. Okay, so I'm going to share my screen, and we're going to go with this. So this is a reminder. It's practice. It's revision, and we're going to start with stuff really fairly simple, and it's going to become very, very much more complicated quite quickly. Okay. So hopefully in less than 1 hour, you will have a good idea how to do things and it will all make sense. So the first thing is, there were 3 triangles which we used for trying to remember how to calculate moles. So what I'd like you to do now is just to try to remember these 3 triangles. Now the 3 triangles, one was for masses, and it used a relative formula mass, or RMM or RAM. One was for concentration and volume of solutions, and the last one was for volume of gases. So just see if you can remember what those triangles, I will show you them in just a moment. Just see if you can remember what those triangles looked like. Just see if you can write them down. If you want to show me them, that's fine. If you don't, that's also fine. I will be showing you all 3 of them because we will be using them. Kabiro are looking very sharp today. Dandora girls are looking quite broken. Mathari mixed. Can you remember? Can you remember the triangles? If you can't, don't worry. We will look at them. We will look at all of them. Silver Spring. I don't know if you were here when we did this. The 3 triangles are very useful. They are ways of calculating the number of moles of a chemical, whether it is a solid, a solution, or a gas. Oh, Dandora girls have an answer. That's one of them. Well done. Very good. Dandora girls have one of them. They have the mass one. Let's see if we can get the solutions one. Anybody else? Anybody else going to come up and share it? So the second one was for solutions, and that had moles and concentration and volume in it. Moles and concentration and volume. We will look at all of them in a minute. If this doesn't make much sense, don't worry. We will look at all of them in just a minute. Anybody got a second triangle? Either the gases one or the solutions one. Anybody? Kabiro. Kabiro coming up. Nearly. Not mass at the top. Not mass, but moles at the top. Very good. Well done. It's concentration and volume at the bottom, but it's moles at the top. Well done. That's very good. Anybody else? Whoops. Okay. The first triangle. This is useful. If anybody doesn't remember this, that's totally fine. But if you don't remember it, then just might be worth writing it down now. So here we go. The first triangle is for things that we weigh out. We can weigh a gas, but generally we weigh solids and liquids. And the way to remember it is moles ram underground. Like moles are they're like little rat things, well, quite big rat things that live underground. And The idea is that they push the earth and they pull the earth, so they ram it underground. Now, the reason that works is because we have moles in the triangle down here, moles, ram here, and G, which is obviously for grams, not for ground, but it makes you remember it. Moles, ram, under G. Okay, so G is at the top, mass is at the top. So if you don't know this already, it would be worth writing it down, even if only one person writes it down in the class and shares it with other people later. That would be okay. The second one is slightly different, and some people got it. Hello, did somebody want to say something? No? Okay. Solutions. Moles is at the top in solutions. And as somebody showed me earlier, concentration and volume are down at the bottom. But the volume has to be divided by 1,000 if it's in cubic centimeters. Okay, so if it's in, like, if they say 25 cubic centimeters, then you have to put 25 over 1,000. That's because concentration is in moles per cubic decimeter, not cubic centimeter. Okay, moles at the top, concentration, volume over 1,000. Now, I haven't said, to those of you who haven't seen this before, all you have to do if you want to work out one of them is to cover it up. So if I want to work out the moles in a solution, I just would cover up the moles, and I'd say moles equals concentration times volume over 1,000. Very straightforward. If I want the concentration, it's the moles over the volume over 1,000, and so on. Okay. The last one, because we're going to be using them in just a minute, is the one for gases, and it looks like this. Normally gases, we have it in cubic centimeters, but sometimes it's cubic decimeters. So moles is down at the bottom again. Cubic centimeters, the volume, is up at the top. And a number which you don't have to remember, which at room temperature is 24,000, but at STP is 22,400. You do not need to remember it. They will tell you this in any test. Okay, so if you want moles, it's the volume over 24,000. In other words, if it says how many moles in 200 cubic centimeters of carbon dioxide, then it's 200 moles equals 200 over 24,000. Okay, so there's the three triangles. This first one, moles, grams, RAM, RMM, RFM, doesn't matter. Then there's the solutions one, moles here, concentration times volume over 1,000. And the last one is the gases one, where it's moles at the bottom, cubic centimeters at the top, and so on. So here we have some questions, and you will have to use each one of those three triangles. So I'm going to give you three questions that you can have a go at. A uses the first triangle, B uses the second triangle, the solutions one, and C uses the third triangle. So just see if you can use those three triangles. If you've forgotten the triangles, or if you want me to show you them again, I could, but it would be really good if you have a calculator just to get used to using these. So in each one of these, it's asking how many moles. So the first triangle says moles equals grams over RMM. The second one, moles, is concentration times volume over 1,000. And the third one, moles, is the volume over 24,000. Just have a go at those, and when you think you've got the answers, do by all means come and show me to any of them. We'll take some minutes to do this. Everybody have a go. Kabiro are looking very keen. Silver Spring, it's a shame I can't see you, but nevertheless, you're very welcome. Dandora Girls working well. Mathari Mix working very well. I'm very pleased. Oh, Kabiro working very well. I like that. Very professional. Okay. Oh, Silver Spring has disappeared, I think. Oh dear. Poor old Silver Spring. Anyway, everybody have a go. Silver Spring will be able to see the recording later if they want to. I hope that Yestin, you've gone off to fix your bench, and Sophia has gone to eat the rest of her birthday cake.
I haven't gone off to fix the bench. I'm listening to the information about moles again. Loving it.
Well, loving it, loving it, loving it. Well, the idea is, I said before you were here, I think, every month I'm going to do a revision session because I reckon it's the best way to learn stuff.
I heard it. I got it. Yes.
Okay.
Love it.
Review it. Get it fixed. Thanks, boss. So, has anybody worked out any of the answers so far? I'll be very impressed by anybody who can show me an answer to any of these. Oh, we have one. Hang on. I'll just pin it. Oh, make it large. Hang on. Just a moment. Just a moment. Oh, where's that gone? Oh, you've disappeared. Hang on. Let me make it bigger again. Sorry. Hang on. Just Dandora. 0.55. No. No, it's the first triangle says moles is grams over RMM. It's grams over RMM. Okay. So the first one is going to be a very small number because we're starting with 0.0055. What's the RMM of CaCO3? Who can tell me what the RMM of CaCO3 is? Anybody? Anybody tell me? Switch on your microphone if you want and just tell me what the RMM of calcium carbonate is. That's better. Sorry, say it again, Kabiro.
100.
It is 100. Very good. Well done. Yes. So the moles, as is being shown by, oh, nearly. Hang on. Not 52. No, it's not 52. CaCO3 will be, we have to add up all of it. So exactly as one of the great scientists in Kabiro said, it's 1 calcium, 1 carbon, and 3 oxygens. So it's 40 and 12 and 3 sixteens, which makes it 100. Okay, so the RMM or the RFM of CaCO3 is 100. So, Dandora girls, do you want to show me again? Yes, Dandora. Yes, Kabiro. Well done, both of you. Well done. Move on to the second calculation. Well done. Very good. Very, very good. I'm very pleased. Well done. I'll show everybody else how to do it in just a minute. Those two teams. So, Mathari, so the first triangle says that moles equals grams over RMM. If the RMM is 100, then the moles is 0.0055 divided by 100. And somebody there has got the answer. Do you want to show me? Do you want to show me, Mathari? I think somebody has got the answer. Nearly, no, it's not 40, 20, 10. No, it's 0.0055 over 100, not over 40, over 100, because the RMM is 100. I'll just show you that while everybody else just has a go at the second question. I'll just show you that on my other. I'm going to just stop sharing for a minute and I'll show you it. So I'll just go back to my board and hopefully I'll be able to show you. So here we go. So, Mathari, here we go. Hello. So, if the triangle says moles is here, RMM is here, and grams is up here. I hope you can see that. Can you see that okay? Yes, just about. So if I want moles, I take moles and equals grams over RMM. So moles equals grams over RMM. Now, the RMM is for CaCO3. Calcium is 40, carbon is 12, and each oxygen is 16, so 3 16s, 48. It's 100. And therefore, if the RMM is 100, that here, it asks for 0.0055 grams, and that goes over 100. If I divide by 100, I move the decimal place 2 places in this direction, so this would become 0.000055 moles. Okay, so moles is grams over RMM. I find the RMM, it was 100. I put the grams over the RMM, that over that equals this. Okay, I hope that's helpful. Okay, I'll come back to my other camera and share my screen again if I can. Okay, second question. The second question was how many moles in 25 cubic centimeters of 0.05 moles per cubic decimeter. Now the second triangle showed this here. So it tells us that moles equals concentration, that's moles per cubic decimeter, times the volume over 1,000. Okay, moles equals concentration times volume over 1,000. So here we are. Here's the question. So moles equals that 0.05 times 25 divided by 1,000. Has anybody got an answer? Anybody got an answer? Oh, Kabiro. Kabiro having a good day today. I'm very impressed with Kabiro today. Oh, hang on. Let me just see what you've done there. Sorry. Can you show me? No, it's not over. Not over. In the triangle, if you look at the triangle, let's go back to the triangle just a minute. I'll be with you in just a moment, Dandora. Here's the triangle. Whoops. Here's the triangle. And it says moles equals concentration times multiplied by volume over 1,000. Okay, so we work out the volume over 1,000 and multiply that by the concentration. Okay, so here's the question. So the volume is 25 cubic centimeters. I'm gonna see it in a minute, Dandora. Hang on just a moment. I will be with you in just a moment, I promise. So we need to work out the 25 over 1,000 and then multiply that by 0.055. Okay, Dandora, let's have a look. Let me just have a look. Yes, Dandora, I think so. Oh, and Mathari mixed coming to the fore. I think you said that. I think you got that right. How many? Sorry, just show me again, Mathari. Just one too many zeros, I think. Let me just have a look. Yes, Dandora. Yes. Yes, Dandora. Well done. Kabiro, slightly too many zeros. It's look at it again. It's got one too many zeros, Kabiro, but very close, very close. Mathari, up a bit, please. Yes, well done, well done, well done. Very, very good. Well done. I'm very impressed. I really am. It's very, very good. You know, I know this is quite difficult, but if you can do these, use these three triangles, you will find moles are not as scary as you think. They are quite scary, but they don't have to be that bad. Okay, so let me just show you how to do that one. I'll show you it in just a minute. And the last question is how many moles in 400 cubic centimeters of hydrogen? Hydrogen is a gas. And the triangle, 400 cubic centimeters of hydrogen. Here's the triangle. Whoops, there's the triangle. So moles equals the volume over 24,000. Okay, it's cubic centimeters over 24,000. Go on, Mathari. Yeah. Whoa, Mathari race into the lead. That's a gold medal for Mathari. Well done, Mathari. Excellent. I'm really pleased. What's your name, please? What's your name, scientist? You are now top of the class science. Show me your name, please. Please.
I'm Oscar. Oscar.
Oscar. Professor Oscar. Really good. Well done. Well done. Mathari got the gold medal there, and the silver medal goes to 0 point. Yes. The silver medal goes to Dandora girls. And what's your name, please? Whoop. Not your answer, your name. Your name is not 0.016666. Well, it might be. It might be. I'm going to. I can't see that. It's too far away. Can you show me closer? I still got. It looks like. I can't. Shanies. Cool. Okay, so here are the answers, guys. Here are the answers to everybody who gets. Oh, sorry. Show me again, Dandora. Joan. Okay, sorry, I didn't see that on your exercise book. Really, really good. So Oscar and Joan go to gold and silver medal places for the moment. We'll see if anybody can beat them later. So here are the answers. So just look at how we work it out. So in the first one, it's a mass. So we had an RMM of 100. So moles is the mass over 100, which is 0.000056. Okay. In the second one, it says 25 cubic centimeters of 0.05 mole per cubic decimeter. Moles equals concentration, that's 0.05, times the volume, 25 over 1,000. So it's 0.05 times 25 over 1,000, which is 0.00125. In the last one, what is 400 cubic centimeters of hydrogen? Well, moles is volume in cubic centimeters over 24,000. So it's 400 over 24,000, which is 0.01. We would normally go to 6, 7, rather than just writing lots and lots of sixes. That's partly because we only know 400. We don't know 400.00 or maybe it's 401 and so on. We can't be too precise. Okay, here we go. So here's a little bit more complicated. This is one that uses two triangles. We want to know what the concentration of a solution is. Okay? And if I dissolve 3.65 grams of HCl in 250 cubic centimeters, what will the concentration be? Well, if I think about concentration, concentration is moles over volume over 1,000. Okay? Concentration is moles over the volume, which is 250 over 1,000, but I don't have the moles. So I need to work out the moles, and that means using the first triangle. And I'm going to tell you that HCl has an RMM of 36.5. Okay, 36.5. HCl, RMM, 36.5. So we need to work out the moles of HCl first, and then put the moles over the volume over 1,000, and that will give you the concentration. You can do this, Kabiro. You can do this, Mathari. I know you can. I really do. Dandora, come on. Come on, Joan. Come on, Oscar. Team Oscar, Team Joan. Team Kabiro. Kabiro, everybody works together. Very good. Very democratic. I'll show you how to do it in just a minute. Sorry, a little bit. Hang on. For some reason, pinning isn't working. 0.1. It's not 0.1. It's not 0.1. It's... Oh, sorry. Hang on. Sorry. I didn't realize what you were doing. You have worked out the moles correctly. Now you need to put those moles over the volume over 1,000. Okay? So yes, I didn't see what you'd done, but you had worked out exactly right. So the first thing to do is to work out the moles in 3.65 grams of HCl. 3.65 grams. So that's using the first triangle. I'll just stop sharing so I can show you how this works. I'll just go on to my other camera. Hopefully you will be able to see in just a minute. Okay, the solution triangle, I'll make it a bit bigger. The solution triangle has moles at the top, it has concentration here, and volume over 1,000 here. I don't know if you can see that, I hope you can. Yes, okay. I want to know the concentration. So concentration equals the moles over the volume over 1,000. Now I know the volume is 250. So that's okay. So volume over 1,000 will be 0.25. But I don't know my moles. So then I have to use the other triangle, the first triangle, which is the one for masses, which is moles here, grams here, and RMM here. So for this then, moles equals grams over RMM. Moles equals grams over RMM. Well, it tells me that I have 3.65 grams, and my RMM, I said, was 36.5. So the moles equals 3.65 over 36.5. So that equals 0.1 moles. And that goes here. So now I can do it. Oh, sorry, I'll go back to that one so people can see it. Whoops. There it is. So it's using two triangles. Okay. So the answer anybody got the answer? Well done, Mathari Mixed. Well done. Very, very good. Yes. Well done. Now, I hope you can, that's very good. Well done. I hope you can see why we used two different triangles there. So, Dandora. We've lost another score, which is sad. Okay, I'm going to go back to... Bring it a little closer, please, Dandora. Zero point 0.1 of it equals... I can't quite see it. Can you get just a little bit up a little bit, please? Up just a little bit, please. I know it's difficult. Sorry. 0.4. Yes, it's the right answer. It's the right answer. Well done. Okay. So now, oh, hang on. I've just gone to the wrong view. Okay, so I'm now going to go back and share my screen again. Here we go. So this is, as it says, this is a bit more difficult. Whoops. That's when you get this PowerPoint, if your teachers get this PowerPoint, I hope you can see my screen now. Dandora, can you see my screen? It says part 2 is harder. Good. Okay, at the bottom there is this funny little sign. This is in case you ever want to look at this again. It just has me explaining, not written but orally, so it has a funny thing with my voice on. You just have to press play and it works. Okay. But I'm here, so we'll do it this way. So here we go. So from the second triangle, we know that concentration is moles over the volume in cubic decimeters. So we need the moles and the volume, and we're given the volume but not the moles. So that's where the 3.65 comes in. So we use the first triangle for that, which means we can then find the moles. That's 3.65 divided by 36.5. That's 0.1 moles. 0.1 then goes over the volume. The volume is 25 over 1,000, 0.25. So it's 0.1 over 0.25, which is 0.4. Well done to everybody who did that. Now, we're going to move on to something different. And there's something else we're going to do is the next bit of moles which we did, which were called empirical formulas. You may remember empirical formulas, and I introduced you to this person here. I said, this is the way that I get my students to remember how to do empirical formulas. And it's not really about being a doctor. It's the first 4 letters, IMDR. So I'll go through one example and then I'll let you have a go. So here we go. It's remembering I'm doctor. IMDR is the important bit. Okay, so IMDR, it works like this. So here's a question. A chemical consists of 70% iron and 30% oxygen, and it's now the RAMs are 56 and 16. Okay, simple. I've got to tell you that now here in the UK, or in this part of the UK, it's not only thundering, but it's also snowing, which is great. Okay, so here we are. So IMDR is information moles divide ratio. Okay, IMDR is information moles divide ratio. So what I've put down my FE and my O, and my information from the question told me 70% is iron and 30% is oxygen. Then I find moles. Now this is like it's in grams. So it's grams over relative formula mass, or RAM, because it is a relative atomic mass at the moment. Okay. And so here we are. So for moles, for iron, it would be 70 over 56. And for oxygen, it would be 30 over 16, because that's the RAMs of the two of them. So information, then moles, and that gives me the moles are 1.25 for iron and 1.875 for oxygen. So then I have divide, D for divide, IMDR, divide, and I divide both of the numbers, or if there are three of them, all of the three, by the smallest one to find the ratio. So 1.25 is smaller. So 1.25 over 1.25 is 1. 1.875 over 1.25 is 1.5. But I can't have 1.5 atoms of oxygen. So I need to double both of them to get them so the ratio stays the same. So I double both of them and it comes out as 2 Fe and 3 oxygens, and therefore it's Fe2O3. So IMDR, information, find out the moles by dividing the mass by the RAM, and then divide all of the numbers by the smallest one, and that gives me the ratio. Sometimes the divide gives you the ratio anyway. Okay, here's one for you. So this one is 37.2% carbon, 12 is its RAM, 7.75 hydrogen, which is 1, and 55.0% chlorine, which is 35.5. So IMDR, have a go with IMDR. See if you can work out what this is. Okay, just have a go. 37.2 carbon, 7.75 hydrogen, 55.0 chlorine. I just need to get a glass of water because my throat is drying out. How are we getting on? Has anybody got an answer? IMDR, so just information, then the moles, which are the percentage divided by the RAM, and then the next column is divide those numbers by the smallest one of them, all of them by the smallest to find the ratio, and then just write it down. So there are the numbers. Mathari, have you got an answer? Wow, this is great. These guys are really good. Oh my heavens. That's Mathari. Have got it. Hang on. Sorry, whoops. Hang on. Mathari and Dandora and Kabiro all got it. Wow, I'm so impressed. I'm so impressed, guys. That is really, really good. Well done indeed. Okay. I'll show you another one that you can do. I'm not going to ask you to do it. We're going to move past this. The answer is C2H5Cl, which is chloroethane. Here's another way that they do it, that they would show you it. Don't bother doing it, but just look at this, just for a minute. This second one. An oxide of copper is reduced to copper. It weighs 1.59 before, and after it weighs 1.27. 1.59 drops to 1.27. Let me just show you on my other board what that means, okay? So some of you might want to have a go at it, but I'm just going to show you how it goes. So if we have copper oxide and it goes to copper and something else, like we might use hydrogen, and in which case the hydrogen would take the oxygen away and it would make it into water. That doesn't matter. So we started with 1.59 grams here, and we get 1.27 grams here, and therefore 1.59 minus 1.27 equals the mass of oxygen that is lost. And then you would do IMDR, and you would have the copper and the oxygen. So the copper is 1.27 and the oxygen is 0.32. Okay, so that's how you would work it out. 1.27, because that's the copper on its own. This was the copper and the oxygen, so it ends up like that. Okay, all right. I hope that's useful. Let me just go back. I'm coming back. Oh, there I am. Wow. Okay, I just need to share my screen. Okay, here's a proper examination question. I hope you can see, Dandora, can you see one that says a solvent is made from? Cool, excellent. Okay, everybody, this is a proper examination question worth 3 marks. A solvent is made from 54.55% carbon, 9.05 hydrogen, 36.36 oxygen, and it has an RMM of 88. Now, to do this, you do IMDR to work out the empirical formula, and then you have to work out what that would weigh and see if it weighs 88. If not, it will probably be 44 or 88 or etc., a multiple. Okay, so if you want to have a go at that one, that would be good. because it is one that I think you can do. 54.55, just IMDR will take you no time at all. I know you can do it. And then we will move on to the last part of it, the last part of the lesson. We're nearly done. We've only got 15 minutes left. You've been really, really good, guys. Very, very good. Kabiro keep on disappearing, which is sad for them. Well, maybe it's happy for them. It's a shame for me. Hey, Mathari, don't give up yet. You've only got 14 minutes, and we're going to do one more. Dandora, you can do this. Recapture the gold medal. Mathari, let's have a gold medal again. Come on, you can do it. It's a race. Dandora against Mathari Mixed. If you do the calculation, Mathari Mixed, I promise I won't sing a Liverpool song to you. That's probably a good idea. Anybody get this? Oh, we've got somebody from Dandora. We've got somebody from Dandora thinking they can do it. C3H50, C3H50, C3H50. Oh, maybe not. C2, sorry, Dandora, show me. C2H40. That's more like it. Okay, everybody. I'm gonna show you how to do it, because what I want to do is I want you not to waste time doing something which I think you can do. So I'm going to show you it now, okay? So the first thing is we do IMDR, okay? Now you have to be careful with IMDR, have to be accurate. So carbon, 54.55. Oh, did you have an answer there, Mathari? C2, sorry, get it a little bit, oh, hang on. Why is this not moving for me? Hang on. Little bit, oh, C2H30, not C2H30, it's C2H40, but you've got exactly the right idea with the finding the molecular formula. That's really good. So here it is, the first bit, IMDR, simple, 4.5, 9.09, 2. And divide through by the 2.2725. We get 241, so it's C2H40. But, and that's 2 marks out of the 3. And then we work out what C2H40 would weigh. Its RMM would be 44. The RMM is 88. So we need to double the formula, and so it becomes C4H8O2. C4H8O2. I hope you can see how that works. Mathari, well done on working that out. Okay, Dandora, I've got your message. I'll have a look at it. I'll have a look at it for you. I'll explain that that last bit there. Is it the last bit that you want to go through, Dandora? Yeah, the last bit? Okay, I'll show you. So I'll stop sharing there. Okay, I'll do it on the other board because it makes more sense. Okay, if I have an empirical formula and I want to find the molecular formula, what I have to do is I have to work out what the empirical formula would weigh and compare that with the RMM. Let me give you an example. Let's say that we have an empirical formula HO. Let us say that the RMM is 34. Now, if it was HO, then HO would be just one hydrogen attached to one oxygen, and hydrogen weighs 1 and oxygen weighs 16, so this would have a RAM of 17. But 17 is half of what a whole molecule weighs. And therefore, instead of it being HO, it's H2O2, twice as many of everything. Let's have another example. So let's have one which works out as CH2O. Okay, but the RMM is 180. Well, if I work out what this weighs, this is 1 carbon, 12, and 2 hydrogens, 2, and 16, and that is 16, 18, 30. But they have told me that the RMM of one molecule is 180. So it can't be CH2O because that's too light. It's not heavy enough. So I say, okay, what is 180 over 30? Because that's the number of CH2Os I will have to have. And the answer is 6. So it's 6 times all of this. So it will be C6H12O6. That's glucose. The empirical formula tells us the simplest ratio. The molecular formula is what the whole molecule really is. So glucose, to lots of machines, glucose, when it is smashed up, looks like 1 carbon, 2 hydrogens, 1 oxygen, because that's the simplest ratio. But the whole molecule weighs 180. This one only weighs 30. So this is 1/6 of the whole thing. I hope that helps. Is that a bit better, Dandora? Cool. Excellent. Okay, last bit. Nearly done. You've been really, really patient and you've worked really hard. Well done, Mathari Mix. Well done, Dandora girls. It's a shame that others weren't here. But anyway, here we're sharing screen again. Here we go. So here's this one again. Here's the whole thing. There's the IMDR. That tells me that the whole molecule must be, well, the empirical formula, the simplest ratio is C2H4O, but it weighs twice as much as that would weigh, so it has to all be doubled, C4H8O2. Okay, the last bit is about reacting quantities. And I want to just show you something that gives you a bit of an idea about how these work. Let's say that we have A and B which react together to give C and D. It doesn't matter what they are. They could be zinc and hydrochloric acid, make zinc chloride and hydrogen. Doesn't matter. In a question, they often ask you, if you start with a certain amount of A, how much D will you get? And the way to do this is to put down the amount of A that they tell you in the question. to then turn that into the moles of A. Then we need to look at the equation which tells me the ratio of A to D. Like sometimes it's one of these gives two of those, or something like that. And therefore I've got the moles of this, and I can work out the moles of D. So let's say it was 1 to 2, and I had 1 mole down here of A, then I would get 2 moles of D. That will allow me then to use another triangle to work out the quantity of D, whether it's the volume of a gas or the mass of a solid or whatever. I'm going to show you one example on my board behind me. Okay, so I'm just going to show you one simple example, hopefully simple, behind me. This is the way that I do it with my students, and they seem to find it really fairly easy after they have got their ideas straight. So let's say that we are going to start with some calcium. I'm going to make it very simple, this one. I take calcium carbonate, I heat it up, and it becomes calcium oxide and carbon dioxide. And let's say in the question they want to know what volume of carbon dioxide will be produced by a kilogram of calcium carbonate. So what I do is I construct a set of boxes. And they look like this: a small one, then a big one, then a small one, then a big one. Into the first one, I said if I start with 1 kilogram, 1 kilogram is 1,000 grams. So in here, I'm going to say I know I start with 1,000 grams of calcium carbonate. Here, in this one, I work out the moles. Sorry, that pen isn't very good. Moles equals, for this, it's a mass. So it's grams over RMM, grams over MM. The grams is 1,000, and the RMM of calcium carbonate, which we came across earlier, is 100. So that equals 10 moles. Okay? Small box, big box. Big box always uses a triangle. I then look at the ratio, and 1 calcium carbonate gives 1 carbon dioxide. I just look for the number in front of them. There's no number, so it's 1. So it's 1 to 1. So 10 moles will make 10 moles. Simple. Down here, it wanted the volume of carbon dioxide. The volume triangle says that volume of a gas is equal to the moles times 24,000 cubic centimeters. So that is 10 times 24,000, which equals 240,000 cubic centimeters, or 240 cubic decimeters. That's how it goes. Now, I hope that makes a bit of sense. You write down what you know first, then you turn that into moles, then you use a ratio to work out what the moles are over here, because a molecule of this gives a molecule of that, so a mole gives a mole. So this is the moles here. Then they wanted volume, so I used that third triangle, volume. For the gases one, moles was at the bottom, 24,000 on the bottom, and the volume was at the top. So the volume equals the moles times 24,000. 10 times 24,000 is 240,000, or if you wanted it cubic decimeters, divide by 1,000. That's 240 cubic decimeters. Okay. Last bit. Promise. I promise it's the last bit. What time do we have? Okay. I'm just going to show you the question. We're not going to do it because you've been brilliant. I'm just going to show you how it works. Okay. So this is That's how we set it up. Here's a real question. Okay, and I'll just show you it very fast now. It says 1.96 grams of zinc reacted with 100 cubic centimeters of 0.2 hydrochloric acid. It says find out which was in excess. This is a real KCSE question. And then the total volume of hydrogen that was produced. And it gives you the equation. So let me just show you how it works very briefly. So we look at the equation. So we had 1.96 grams of zinc. And so we use the first triangle, 1.96 divided by 65. That's about 0.03 moles. For the hydrochloric acid, we have 100 cubic centimeters of 0.2. Moles equals concentration times volume over 1,000. So there it is. And that's 0.2 times 0.1, which is 0.02. So 0.03 over here, 0.02 over there. There is more zinc. Okay? That's how you do it to start with. And then you say, okay, that's 2 marks. And then you take the zinc and you say, okay, from the zinc, the volume is moles times it's at STP, which is 0 degrees Celsius. They would tell you the volume. For a gas, volume is moles times 22,400, 24,000, or 24 or 22.4. 2 moles of HCl makes 1 mole of hydrogen. 0.02 moles will make 0.01 moles, and therefore it's 0.01 times 22.4, which is 0.224. Now that is too fast. Okay, I understand that is too fast, and I'll try and show you that at the beginning of next time, but that's it. For the person who had a question about some sodium hydroxide which was neutralized by sulfuric acid, the answer is 0.125 mole per cubic decimeter. I'll show you how to do it next time if you want, but I'm going to stop recording.